All right, this is Everybody Codes, day 16. That looks straightforward. Uh, 244. Getting the wall. Let's see. 944 something 954. Right. Okay, so that was the day. So what's going on here? So we are, I don't know. In part one, we're given this list of numbers, and the idea is that the way to explain this is not just the story of the problem. Maybe the story of the problem is fine. Like, since 1 is in the list, we're dropping a block on every column. And since 2 is in the list, we're dropping a block on every second column, and so on. The question is, how many things are in the list if the list is of length 90? So fine, if x is in the list, that just means 90 over x blocks, and that's it. In part 2, we say, okay, given how many blocks were dropped in each column, tell me what the list was. So what's going on here? Basically, we go through each column, and we need to subtract off the blocks that we know were dropped due to previous columns, and then we can figure out how many blocks were dropped in this column. And also, it turns out that they only drop at most 1 block per column, which simplifies things a little bit. Okay, so like if there are any blocks in column 1, that must be because there was a 1. Now we know there's at least 1 block in column 2, but if there's 2 blocks in column 2, that must be because there was a 2. Column 3 has 1 block because of the 1. Well, if there was a 1. But if it has any more blocks, then there was a 3, and so on. So we can sort of go backwards. And then in part 3, we say, okay, we have so many blocks, and here's the fragment. So basically, first do part 2, and then say how many columns can we build with that sort of set of constraints. So like here's the list of columns that we're dropping. We're dropping blocks for any multiple of these columns. And then, right, so like first we run part 2 on the input, and then we run sort of part 1 on the input with a binary search. So I'm going to binary search for the number of columns. You know, it's at least 0. It's at most 10 to the 30. I think that's probably safe. And then we say, okay, let's check the middle. So we know from part 1 to compute how many blocks are required for that length. And if we can make that length, then the answer is at least that big, and otherwise the answer is less than that. And we query low plus high plus 1 over 2, so that if we're not sure if it's like 10 or 11, we should query 11, because then we'll either go to 11 to 11, or 10 to 10. And we can print out the final answer at the end. So that's it for today. See you tomorrow.